Have you ever wondered what lies beyond our solar system? Other planets, black holes, massive galaxies, even extraterrestrial life? There's a lot of math and science behind the answers to our universe, but let's start with defining what exoplanet outgassing actually is. When you look up at the stars, billions of miles away, many of them have their own planets. In astronomy, we call them exoplanets, but they're really just planets way outside of our solar system. Outgassing is a little more complicated, but it happens here for us to see on Earth. Under the crust, there is a moving layer called the mantle. It's made of molten rocks called magma that have particles like carbon, oxygen, sulfur, and lots more trapped inside of them. As the Earth's tectonic plates shift, some of this magma is pushed through the crust and expelled into our atmosphere. The most well-known examples of this process are volcanoes. As the magma is spewed into the air, it releases the particles as gases that fill our atmosphere. Scientists call this process outgassing. Unfortunately, exoplanets are so far away that even our most powerful telescopes can't see what they look like. Instead, astronomers gather information about exoplanets from their transits. When a planet eclipses its star, we can measure its radius from the very small dip in the star's light that we see from here on Earth. With an exoplanet's radius, scientists are able to calculate its mass, temperature, and many other helpful variables. In my research, I use this information to predict what atmospheres look like on exoplanets. Take the TRAPPIST-1 system, for example. By plugging in data about the star's mass and information about its planets to the program I've written in Python, I can predict how thick each planet's carbon layer will be due to outgassing. But instead of looking at just one exoplanet, I was able to plot what many exoplanets' atmospheres might look like and see the trends in carbon scale pressure height due to different variables such as the planet's mass, orbital period, and semi-major axis, which is just a measure of the distance from its star. While being able to predict what exoplanet atmospheres may look like is super cool, why is it important? The search for extraterrestrial life is a difficult thing, with there being so much criteria for a planet to host life. Scientists may be able to narrow their search by looking at my predictions to rule out planets with very small atmospheres, or no atmospheres at all. It's a small step towards a big goal, but that's what space exploration is all about.